viewers, welcome to CEC lectures. Myself Dr. Preeti Ramani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So today we are going to finish our virtual functions in this lecture by covering the topic of hierarchy of virtual functions. Till this point we have seen some of the lectures of virtual functions in which we have established clearly established that what actually a virtual function is and how these virtual functions are inherited. We have also seen the mechanism of pure virtual functions. In this class we are going to see how these virtual functions are behaving in a hierarchical manner. So, when a function is declared as virtual by a base class, it may be overridden by a derived class. Now, why I am saying it may be overridden by a derived class? What will happen if a derived class fails to override a virtual functions? Then in that situation, when an object of that derived class accesses that function, which version will be used, because the derived class is already failing to override the virtual function, and now the object of that particular derived class is trying to access the function. Then base class comes here into the picture as a savior. The function defined by the base class is used. Let us try to see what is happening and within the program how we can do that. So, we have one class base. Within the public section we have one vfunc, which is a virtual function, and it has been declared with the help of the keyword virtual. It says virtual void vfunc without the parameter list, and within the body of this vfunc we have only one cout statement which prints this is the base v function, and the definition of the v function as well as the definition of the class base ends here. Now, we have one class which is derived one. It is inheriting the class base in the public manner, and within the public section it is redefining the function vfunc, that is a virtual function defined inside the base, and it is printing as cout, this is derived one's vfunc. Another class we have derived 2, which is also inheriting the base class, which is the in the public manner, which is named as the class base, and it is having its public section blank. So, why I have seen why I have left its public section blank is just in order to put stress on the fact that vfunc is not overridden by derived 2. So, what will happen? So, what is going on here is we have one base class which is having one virtual function, and please remember this is not a pure virtual function. If this would have been a pure virtual function, this scenario would not have been possible, that one derived class is in redefining it and another derived class is not redefining it. So, here we have given the normal virtual function, not the pure virtual function. So, we have a virtual function defined by class base as vfunc. This is base vfunc that is printing. Now, one class which is derived 1 is inheriting the base class in the public mode, and it is also, I can say, overriding that particular virtual function and giving its own redefinition of that virtual function. While another class which is also inheriting the class base but not providing any redefinition of this virtual function declared inside the base class. Now, coming to the main, we have one base pointer and we have one object of the class base. So, for that base pointer we have base asterisk p, and for this base object we have base b. Similarly, we have object of derived 1 as named as d1, and for the class derived 2 we have object d2. Now, what is happening? P is the pointer to the base class, and therefore it can contain the pointer to the base object. So, P is equals to %B. That means here P is pointing towards the object of the base class, and then we are saying P is also accessing that vfunc using the arrow operator. So, now what is happening here? Here the object of the class is of the base class, the pointer is also of the base class. Both the situation, pointer is also of the base class and we are also storing object of the base class. So, within this scenario, whenever we are using this vfunc, it will automatically access the base class version of the vfunc, because we have not kind of, we can say, intervene with any other object here. So, that's a clear scenario. But now in the next step, when we are making the pointer P to point to the object of the class derived 1, which is D1, by writing the statement P is equals to ampersand D1, and now we are trying to access vfunc with the help of P through an arrow operator by writing the last statement, which is P arrow operator vfunc. It is going to access derived 1's vfunc. That is very clear, because derived 1 is already having a definition, its own definition of vfunc. But now when we are saying that this pointer P is now containing, now we are changing the contents of the pointer P, and now pointer P is pointing towards the object of the class which is derived 2. Now, please recall that derived 2 is not having its own definition of vfunc. So, whenever we are trying to use vfunc with the help of P through arrow operator by writing the statement P arrow operator vfunc, this is going to use base classes version of vfunc, because it is not having its own any kind of version of this vfunc. So, as expected, this program is going to give the following output. The first call to vfunc is for base, so it will print this is base vfunc. Then the second call to vfunc is from derived 1, so this will say this is derived 1's vfunc, and the third call is to derived 2's vfunc, but unfortunately that derived 2 is not having any definition of vfunc of its own. So, base classes vfunc will be used here, because your derived 2 does not override vfunc. The function definition defined by base is used when the vfunc is referenced relative to the objects of type derived 2. Now, please try to understand why we are saying that we are studying virtual function hierarchy, because inheritance is hierarchical in C++. It makes sense that virtual functions are also hierarchical. This means that when a derived class fails to override a virtual function, as we have seen in the case of derived 2, the first redefinition found in reverse order of the derivation is used. Now, here I am repeating this statement because this is very important. When a derived class fails to override a virtual function, the first definition found in reverse order of the derivation is used. So, what does it mean? For example, in the following program, let us say derived 2, we are going to discuss a program in which derived 2 is derived from derived 1. It is not derived from the base as in the previous example. In the previous example, your derived 2 was derived from the base class, while here the program, the following program which we are going to discuss in a short while, the derived 2 is derived from the another derived class which is derived 1, which is in turn is derived from base. So here is a kind of, we can say a case of multi-level inheritance. So derived 1 is inheriting base and derived 2 is inheriting derived 1, and the similar situation happens that derived 2 does not override v-func. This means that relative to derived 2, the closest version of v-func is now available in derived 1 instead of the base class, because now derived 2 is not inheriting the base class, instead it is inheriting derived 1. So, the virtual function version of derived 1 that will be used when an object of derived 2 attempts to call v-func. Now, let us try to see this with the help of a program. So, we have hash include iostream and using namespace standard. Within the base class, in the public section, we have virtual void v-func, and this is base version of v-func. This statement or this definition of base class is similar as that of the previous one, while here comes kind of a little twist when we talk about derived 2, but let us try to see derived 1 first. So, we have class derived 1 which is inheriting the base class in the public mode, and in the public section it is giving its own definition of v-func, which says this is the derived 1's v-func. Now, this definition is also similar to the definition of derived 1 of the previous program. Now, coming to the derived 2, here the difference here is the class derived 2, in the earlier version it was inheriting base class in the public mode. That means the statement was class derived 2 colon public base, but here it is not kind of inheriting the base class, instead it is inheriting the derived 1, and within the public section there is nothing, because we do not want this class derived 2 to have its own version of v-func. So, public section here is, we can say, kind of empty. Now, coming to the main function, similarly as that of the previous program, within the main function we have one pointer to the base class which is p, shown by base asterisk p, one object to the class base which is named as b. So, base b we have, then object d1 is of class derived 1 and object d2 is of class derived 2. Now, what is happening? We have p as the pointer and we say p is equals to ampersand b. That means this time this p is actually pointing towards the object of the class base, and in the next statement we are trying to call the v-func using the p pointer through the use of arrow operator, which is p arrow operator v-func. So, here as in the previous case, the pointer is of base class, the object whose address is stored inside the pointer is of the base class, and we are also calling the v-func using that particular pointer, and within these two statements there is no kind of, we can say, context of any derived class. So, that is very kind of obvious that here base classes version of v-func is being accessed or is being addressed for. Now, what will happen when we have a pointer p, which is the pointer of the base class, and that pointer is pointing towards the object of the derived 1 by saying the statement p is equals to ampersand derived 1, and now we are trying to access v-func using that p by the statement p arrow operator v-func. So, that means we are trying to access derived one's version of VFunc. That is also fine, because VFunc is having one version of its own, one redefinition of its own of VFunc. Now let's say this pointer P is pointing towards the object of the class derived 2, and this can be achieved with the help of a statement P is equals to ampersand D2, and with the help of P we are trying to call VFunc with the use of an arrow operator by the statement P arrow operator VFunc. So now here we are using the VFunc version of derived one class. Why? Because in hierarchy, that is the closest version of VFunc which D2 can access. D2 is not, please try to recall that D2 is not having its own version of VFunc. That means within the class definition, this derived 2 class is not having any redefinition of the function VFunc. Now whenever we are trying to use the VFunc using the pointer P, and in the case in which your P is containing the address of the object of the class derived 2, which is not having its own version. So P arrow operator VFunc, whenever we are using this, will try to access within the hierarchy the next kind of the latest function, or the closest function in the hierarchy which is available for derived 2. So derived 2, if you can recall the definition, is inheriting the derived 1. It is not inheriting the base class, it is inheriting derived 1. So here derived 1's function or the derived 1's version of VFunc will be accessed. So this program is going to display the output as this is base VFunc, which comes from the access of VFunc using the first statement where P is equals to ampersand B was defined, and then we say P arrow operator VFunc, this is accessing base VFunc. Then we said P is equals to ampersand D1 and P arrow operator VFunc, that means this is using derived V function. Now coming to the last statement where P is equals to ampersand D2, and we have P as accessing excess of P excess of VFunc using P and arrow operator, but this will give you the output that this is derived one's VFunc, because that is the kind of closest function in the hierarchy that will be used by derived 2. So these two, in these two programs, what was the difference? One, in the earlier program, the derived 2 was inheriting the base class, and here the derived 2 is inheriting the derived 1. Now here in this situation, derived 2 can access the base class version of VFunc also, but the latest in hierarchy or the closest in hierarchy is not the base. The closest in the hierarchy for derived 2 is the class derived 1. So that will be used. That is the difference between these two programs, and here we are we have established that how hierarchy is going to play a major role in the in the functionality of virtual functions. So the closest hierarchical function will be used if the derived class is failing to give its own version of the V function. So if the derived class is not giving any redefinition of its own function, it's any definition of its own of the virtual function, so the virtual function version which will be used, that will depend on the closeness of the hierarchy. Now, with this, after understanding the hierarchy closeness of the virtual function and its impact for the implementation, let us try to see what are some rules for the virtual functions. So, first rule for the virtual function says virtual functions can not be static. We cannot have static virtual functions. Then the next rule says a virtual function can be a friend function for of another class. So, it is perfectly allowed to have a virtual friend function, and this virtual friend function will be defined by these the two key terms. One is virtual, another one is friend. So, we will say virtual friend, then the return type, then the name of the function, and then the parameter list. So, it is perfectly allowed to have a friend function which is a virtual function. So, a virtual function can be a friend function of another class. Then, in order to achieve runtime polymorphism, the access mechanism of virtual function should be taken care of. That means, virtual functions should be accessed using pointers or reference of the base class type in order to achieve runtime polymorphism. That means, if we want to have runtime binding or late binding, we can say the virtual functions should be accessed either with using the pointer or using the reference of the base class, because in the earlier classes we have seen reference is also a a pointer internally, or we can say a pointer and reference can be used in somewhat an interchangeable manner. So, in order to achieve runtime polymorphism, we will not use only the objects and the dot operator, because that will not work to achieve runtime polymorphism. Only the pointers or the references of the base class are going to help us in order to implement runtime polymorphism. Apart from that, we need to see that a prototype of virtual function should be same in the base class as well as in the derived class. Now, this condition goes without saying that the prototype of virtual function should be same within the base class as well as in the derived class. Why? Just because, for the simple reason that if the prototype is going to be different, this will not be called as kind of virtual function, that will be taken as the function overloading, because function overloading wants you to have different prototypes in the base class or maybe in the derived class. So, also there are always defined in the virtual functions are always defined in the base class keyword virtual and overridden inside the derived class. So, it is not mandatory for the derived class to override or redefine the virtual function. The derived class may go without the redefinition of the virtual function, and in that scenario the base class version of the function is used, and that we have seen in the previous program that the closest version of the function of the base class will be used. Also, a class may have virtual destructor, but it cannot have a virtual constructor. That is also a very important and important rule of the virtual functions, that a class may have virtual destructor, but it cannot have a virtual constructor. Now, these were some rules of virtual functions. Apart from these rules, there are some limitations of virtual functions. Although virtual functions are serving as great tools for in order to achieve runtime polymorphism, but there are two limitations of virtual functions. One is they are slower, and another one they are difficult to debug. So, the function call in case of when we are talking about these virtual functions are slower. The function calls take slightly longer due to virtual mechanism and its runtime binding. and it makes more difficult for the compiler to optimize, because the compiler at the compile time it's not aware of which function is going to be called. It is going to be binded at the runtime. So definitely it will take a slightly we can say longer time. Also in a complex system, when we talk about the debugging scenarios, in a complex system virtual functions can make it a little more difficult to figure out from where a function is being called. So the two limitations are, one is it is slower, another one it is difficult to debug. So in this lecture what we have covered is the hierarchical nature of virtual function when a derived class is not redefining it. Also we have seen some rules of the virtual functions and couple of limitations of the virtual functions we have also seen. This is a list of references which is being used for the preparation of lecture. Hope you had a fruitful learning. Thank you.